Hello everyone, welcome to new class. Today's class is the continuation of matrices. So next topic is multiplication of matrices. Let A is equal to matrix Aij with order m by n, and let matrix B is equal to Bij order n by p. So, two matrices A and B can be multiplied if the number of columns of the matrix A is equal to the number of rows of the matrix B. So, the product of two matrices A and B is defined as it is possible only if the number of columns of matrix A is equal to the number of rows of matrix B. So, two matrices A and B can be multiplied only if the number of columns of the first matrix is equal to the number of rows of the second matrix. And what about the order of the resultant matrix? So let the multiplication of the two matrices A and B is equal to matrix C, and the order of this matrix C is, so here this is matrix A is equal to Aij with order m by n, and here this is matrix B jk. So this is bjk with order n by p. Then the resultant matrix C is cik with order the row of matrix A and column of matrix B, that is m by p will be the order of the resultant matrix C. So here this matrix is Aij with order m by n, and this is matrix B bjk with order n by p. So here the number of columns of matrix A is equal to the number of rows of the matrix B. Then the resultant matrix C is equal to matrix Cik with order m by p, that is the number of rows of the first matrix and the number of columns of the second matrix. Next is properties of multiplication of the matrices. So first one is the associative law. That is, consider three matrices A, B and C. So the associative law is A, B into C is equal to A into B, C. So this is associative law. Then second one is distributive law. So distributive law is A into B plus C is equal to AB plus AC. Also A plus B into C is equal to AC plus BC. Next is the existence of multiplicative identity. So for every square matrix A, there exists an identity matrix of the same order such that identity matrix I into A is equal to A into I is equal to A. So here this I is the identity matrix of the same order of the square matrix A, such that I into A is equal to A into I is equal to A. So these are the properties of multiplication of matrices. Now let us do some problems related to this multiplication of matrices. Now let us find how to multiply two matrices. So to multiply two matrices, we have discussed about the orders. Now how will you multiply two matrices? Let us check the multiplication of matrices. So let C is equal to 1 minus 1, 2, 0, 3, 4, and D is equal to 2, 7, minus 1, 1, then 5, minus 4. So here this C is a matrix of order 2 by 3 and D is a matrix of order 3 by 2. So here the number of columns is equal to the number of rows. So we can multiply these two matrices. And what will be the resultant matrix? So CD will be a matrix of order 2 by 2. So this will be a matrix of order 2 by 2. Now how will you multiply these two matrices? So to multiply these two matrices, we have to multiply the first row elements with the first column elements and add, that is multiply corresponding elements of the rows and columns and add. So here the product CD is a 2 by 2 matrix, and how will you find the elements of this 2 by 2 matrix? So here we have to add the product of corresponding elements of rows and columns of the first and second matrices, that is C into D will be equal to, take the first row and multiply each elements with the column of the second matrix and add. Also again multiply this row with the second column. That is, if we take the first row and first column, then we will get 1 into 2, that is multiply each corresponding elements and take the sum. So 1 into 2 plus minus 1 into second one minus 1 plus 2 into 5. So this is the first element of the resultant matrix. Then to get the next element, take the first row and second column. So here 1 into 7 plus minus 1 into 1 plus 2 into minus 4. Then to get the second row, so this is a 2 by 2 matrix, so second 1 and 2. So second row, here also take the second row and do the same procedure as the above, that is second row and first column, then second row and second column. So here we will get 0 into 2 plus 3 into minus 1 plus 4 into 5. So this is the next element. Then the fourth element is 0 into 7 plus 3 into 1 plus 4 into minus 4. So this is the product of these two matrices. Now we can rearrange this one. That is 1 into 2, 2. Then here 1. Then here 10. So 10 plus 1 plus 2 is 13. Then here 7. Then this is minus 1. Then minus 8. So minus 8 minus 1. Then 7. That is minus 2. Then here 0, then minus 3, then 20. So 20 minus 3, that is 17. Then 0, 3, then minus 16. So minus 16 plus 3, that is minus 13. So this is the product of the given two matrices. So in this way we are doing the multiplication of matrices. So here we have to take the sum of product of the corresponding row elements with the column elements. Let us do another problem. If A is equal to 1, 1, minus 1, 2, 0, 3, 3, minus 1, 2, and B is equal to matrix 1, 3, 0, 2, and minus 1, 4. Find A into B. So to find A into B, first of all we have to check whether the number of columns of first matrix is same as that of number of rows of the second matrix. So this is 3 by 3 matrix and this is 3 by 2 matrix. So here we can multiply these two matrices. So to multiply we have to sum the products of the corresponding elements of the first row elements and first column elements. So 1 into 1 plus 1 into 0 plus minus 1 into minus 1. Then next is first row with the second column. So 1 into 3 plus 1 into 2 plus minus 1 into 4. Then in the second row, this one, that is second row elements. So 2 into 1 plus 0 into 0 plus 3 into minus 1. Again 2 into 3 plus 0 into 2 plus 3 into 4. Next is this third row. So 3 into 1 plus minus 1 into 0 plus 2 into minus 1. Again 3 into 3 plus minus 1 into 2 plus 2 into 4. So here we will get 1 plus 1, that is 2. Then here 3 plus 2 minus 4, that is 5 minus 4, that is 1. Then here 2 minus 3, that is minus 1. Then here 6 plus 12, that is 18. Then 3 minus 2, it is 1. Then 9 minus 2 plus 8. So 9 minus 2, 7 plus 8 is 15. So the answer is 2, 1, minus 1, 18, 1, 15. Similarly, here we can find that its order will be 3 by 2. So this is 3 by 2. So in this way, we can multiply two matrices. And in multiplication of matrices, not one thing that AB need not be equal to B into A. That is, the multiplication is not commutative. So AB, so this is one property. So AB need not be equal to B into A. But in some cases, we get AB is equal to B into A. That is very rare. In most cases, AB is not equal to B into A. That is, multiplication is not commutative. Similarly, in some cases, we get the result, that is the result of multiplication of two matrices as the zero matrix. So in some cases we get the multiplication as zero matrix. So in some cases we get zero matrix as the product of two non-zero matrices. For example, if A is equal to 0 minus 1, 0, 2 and B is equal to 3, 5, 0, 0. Then here we will get A into B equal to 0 into 3 plus minus 1 into 0. So it is 0. 0 into 5 plus minus 1 into 0. It is again 0. Then 0 into 3 plus 2 into 0. 0. 0 into 5 plus 2 into 0. 0. So in some cases we get zero matrix as the product of two non-zero matrices. So in the next class, let us discuss more problems related to this multiplication of matrices. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.